Hi there, people. Okay, good day. So for today, I will be dealing about basic CPU scheduling. Okay, so we are done with the discussion of processes. So that's the requirement for the course, and we should fully understand how operating system executes a program. All right. But before we proceed with CPU scheduling, so let's have some recap first regarding the operating system application execution. Okay, so CPU scheduling basically is also known as the process scheduling. Okay, in some books, okay, so they use the term process scheduling for CPU scheduling because we are actually processing or we are actually executing a process. Okay, now for process scheduling, okay, so basically your CPU, okay, will execute a program whenever we run the application. All right. So from the definition of the process is defined as the program and execution. So basically, it starts with clicking the icon on your screen, okay, or tapping an application icon on your cell phones, okay, or iPads, okay. So we are actually creating a process when we tap an application and we run it, okay. So it would start with your application residing on the hard disk, okay, move it into the RAM, and then from the RAM, the CPU will fetch each of the process and then execute it. All right. So the process will go to or will go on three stages. All right. So a process will request a resource prior to its execution. A process will use the resource, and a process shall release the resource so that other processes on the queue will be able to use it. All right. So again, your process would go to request, use, and release. Now on CPU scheduling, okay, so we will be dealing with the basic concepts, the scheduling criteria, the scheduling algorithms, and after that, so we are going to evaluate and compare or compare and evaluate the 6 basic CPU scheduling algorithms. All right. Now for the basic concepts of CPU scheduling, so our target here is to maximize the CPU utilization. Okay, so we have to keep the CPU as busy as possible. All right, and in reality, there is a CPU and I/O burst cycle. So process execution consists of a cycle of CPU execution and an I/O wait. So basically, each process will be given an ample time to execute on the CPU because the CPU has to entertain some I/O requests, okay, or a request coming from the peripherals using the IRQ. All right. Also, you've got the CPU burst distribution. So how are we going to allocate, or how do the operating system allocate, okay, processes on the CPU for execution? All right. Now, we have this term or terminology in CPU scheduling, which is a CPU scheduler. So a CPU scheduler basically selects among the processes in the memory that are ready to execute and allocates one of them to the CPU. Okay, so initially from the hard disk, all right, so your program will be loaded to the RAM. All right, and then from the RAM, the operating system, specifically the CPU scheduler, okay, will select one of the process from the RAM and then move it for execution on the CPU. Okay, so CPU scheduling decisions may take place when a process switches from running to waiting state, switches from running to ready state, switches from waiting to ready and terminates. So if you could still remember the discussion on processes, wherein each process should go through this process stages. So it initially starts with the new, okay? With what when we say new, we're going to create a process. Ready, the process is already in the RAM, okay? Running, the process is currently executed. Waiting, the process is preempted or suspended from execution, okay? And then you've got running, terminating or terminated, which means the process is done with execution. All right? So scheduling under 1 and 4 is non-preemptive, okay? So switches from running to waiting state and terminating is under or is considered to be non-preemptive. So all other scheduling is considered to be preemptive. All right? So I'm going to explain later on the difference between preemptive and non-preemptive. So aside from the CPU scheduler, we have another term, okay, so which is a dispatcher. So dispatcher module gives control of the CPU to the process selected by the short-term scheduler. So this involves context switching, okay, or the switching context, switching to user mode, and jumping to proper location in the user program to restart the program. Okay. So basically, dispatcher is more on the control, okay, whereas the scheduler basically picks or selects among the process on the RAM for execution on the CPU. Okay. So you also have the dispatch latency. So time it takes for the dispatcher to stop one process and start another running. So we call it dispatch latency. All right. Now, what are the scheduling criteria? So as what I've said earlier, we have to keep the CPU as busy as possible. Okay. So the scheduling criteria are the following. So first, CPU utilization. Okay. So as what I've said, you have to keep or we have to keep the CPU as busy as possible. So we want to attain 100% CPU utilization. All right. But of course, in reality, if we are going to evaluate our a task manager, okay, so let me open a task manager here, okay, and see if what our CPU utilization is, okay. Now, using our task manager, so we will see here the CPU utilization, and it's only about 49, okay, or 40% plus, right? Now, if you reach a 100% CPU utilization, the tendency is your CPU will become busy and it might lead to a system hang. All right. So only in principles that we want the CPU utilization to be 100%. But then in reality, so if you will observe here, it ranges from 40 to 70%. That's a good CPU utilization. All right. So, but then as what I'm saying, under CPU scheduling, we have to keep the CPU as busy as possible, and that is to reach a 100% utilization. Okay. Now, throughput is the number of processes that complete their execution per unit time. Okay. So when say throughput, this is the amount of work completed in a unit of time. So in other words, throughput is the process executed to number of jobs completed in a unit of time. Okay, so often you will hear the word job. Okay, job is also the same as process. So in the book of Silber's Chats, they use the term job and process interchangeably. All right, so throughput, the scheduling algorithm must look to maximize the number of jobs processed per time unit. So that's the throughput. All right. So for turnaround time, this is the amount of time to execute a particular process. So turnaround time refers to the time between the moment of submission of a job or process and the time of its completion. Thus, how long it takes to execute a process is also an important factor. Okay, so turnaround time is when the job has finished the execution. Okay, or when the CPU has finished the execution for a job. Next is the waiting time. Waiting time is the amount of time a process has been waiting in the ready queue. Right? So it is the time a job waits for resource allocation when several jobs are competing in multi-programming system. Right? So the aim is to minimize the waiting time. Alright? So minimize the throughput, minimize the turnaround time, and minimize the waiting time. Okay, and then of course we have to increase the throughput. Alright? Next is the response time. So when you say response time, this is the amount of time it takes from when a request was submitted until the first response is produced. So not the output. Alright? So response time is the time taken to start responding to a request. So a scheduler must aim to minimize the response time for interactive users. Alright? So these are our criteria for CPU scheduling. And we have to observe it during the algorithm computations of the waiting time and the turnaround time. Alright? So again, the optimization criteria. So we have to get a maximum CPU utilization, a maximum throughput. Okay, so a minimized turnaround time, minimize waiting time, and minimize response time. Okay, so for our discussion here, this will focus on the turnaround time and the waiting time. Okay,